Alright, hello everyone. So in this video we are going to discuss, let's say we have a sequence and it is convergent. Can we have couple of limits? Can we have more than one limit? Well, the answer is no. You can only have a one limit, a unique limit if it is convergent. So we are going to prove that fact. So let's say proof. Now how are we going to prove it? Well, let's say we have a sequence Sn and we start with the wrong assumption, which is, let's say we have couple of limits, in this case S and T. The sequence is convergent to S and T both. Now we know this is wrong, so ideally we want to prove that, well, S and T are not two different things, it's the same thing. So S becoming equal to T means there's no two limits, there's only one limit. Alright, so let's get started. So to do this we are going to use the definition. Now according to the definition, let's say we consider epsilon greater than 0 a positive number, arbitrary positive number. Alright, so in fact, since the sequence is convergent, for every positive number, okay, there exists a natural number n. Let's call it n1. Let's take the first scenario. Let's talk about these two, okay, Sn and S. Alright, so for the first scenario, for every epsilon greater than 0, we know there exists a natural number called capital N1 such that after every position greater than N1, your distance between terms of the sequence and the limit are even closer than, let's say, epsilon over 2. Now why do I write epsilon over 2 rather than epsilon? Well, I will show it to you later because it's going to be helpful to us later. But really epsilon is a positive number, so epsilon over 2 is a positive number, so it's not a harm to write it like epsilon over 2. Okay, so that's the first scenario. Now we know also that T is also a limit, so we can do the same with using T. So let's write the same thing for the second scenario. So n greater than, now let's say capital N2, where Sn minus, now T, it's getting closer to 2, even than epsilon over 2. We just write epsilon over 2 again. Alright, so we can write these two facts using the definition because sequence Sn is convergent to both S and T. That's what we assumed, right? At least. Alright. Now remember our goal. Our goal is to show that S is equal to T, meaning that they are the same thing, same real number. So S is equal to T means S minus T is 0, right? If they are the same thing, right? So let's try to find out what is S minus T absolute value. Okay, right? So S minus T, now I'm going to use a trick. In between S minus T, what I'm going to do is I'm going to input S minus Sn, okay, and I'm going to add plus Sn. I'm going to add Sn, right? Okay, so this is what I'm going to do. So in the middle here, I input this artificial couple of terms. Well, minus Sn plus Sn is gone, right? It's not there. So actually, still this is S minus T. You can add and subtract anything. It doesn't harm you anything. It doesn't do anything. But it helps us to visualize this scenario better. Now let's have brackets to identify them separately. Still this is S minus T. Now we can use the triangle inequality here for these two terms. So for these two terms that I have expressed in two parentheses. Now according to the triangle inequality, we can say this is S minus Sn plus this term, what I'm writing here, is greater than the term here. Alright, so that's using triangle inequality. Now we know one thing for sure. Because of using fact 1 and fact 2, we know this is epsilon over 2. So that's epsilon over 2. We know this is epsilon over 2. So that's plus epsilon over 2. So now you can see that why we took epsilon over 2, because when we add, really what we get is epsilon, right? Okay, so really what this means is, now here's the important thing. S minus T, right? If you forget all these steps, if you delete all these steps here in middle steps, really S minus T is less than, strictly less than epsilon. That's what we get. Now epsilon is an arbitrary number. Okay, epsilon is a positive number, strictly greater than 0. S minus t is distance between two numbers, an absolute distance. Now here it should be positive. That means this should be greater than or equal to 0, right? Distance should be either 0 or greater than 0. And epsilon is any number, any arbitrary number, positive number. Okay, that means 0 is not included, a number greater than 0. So if the distance is less than every number greater than 0, the only option that is minus t left is this, right? Think about it carefully. So that means s is equal to t. So actually you don't have two limits. This is a contradiction. So you don't have two limits. S is equal to t. Okay, so we have a one unique limit. So that's the proof. That's the formal proof to show that a sequence, if it is convergent, the limit is unique. Okay, all right, so I will see you in the next video. Thank you very much. Bye bye.